creatine is a compound in your body that occurs naturally, but also you can take in largely through meat. It's useful, particularly from a supplementation perspective, because creatine can act as a phosphate donor. Now, what do I mean by that? So if you remember anything from high school biology, when we zoom in on a cell, particularly in this case, a muscle cell, the source of energy within that cell is a molecule called ATP, adenosine triphosphate. And really, when we say energy, it's quite literally chemical potential energy. But the way I think about it is just the ability to kick off reactions. Because if we, again, zoom in on that cell, all of the functions and everything going on are largely, or the way I think about it, just a conglomeration of a bunch of different chemical reactions working together to create, net functions. And adenosine triphosphate is particularly useful in this perspective because it has, just like the name implies, an adenosine molecule connected to three phosphates, right? Triphosphate. And those phosphates all are negatively charged. And just like if you took three magnets and put the negative ends of them together, those three negatively charged phosphates are going to repel one another. They don't want to be stuck together. And so the fact that they are stuck together on that molecule of ATP means that it's really easy for that molecule of ATP to bump into another molecule and pass off one of those phosphate groups. And since that phosphate group is negatively charged, it can initiate some type of chemical reaction with that other molecule that ATP is bumping into, and that can set off a cascade of reactions, right? That's, if there's some chemist, PhD listening to this, they're probably upset that I missed some nuances there, but I think that's kind of the general gist of why ATP is useful. Where creatine comes into play is that creatine can get turned into creatine monophosphate. So it can carry or bind to one phosphate group. And so after that reaction we just talked about occurs, where ATP gets rid of one of its phosphates, it now becomes ADP, adenosine diphosphate, because now it has two phosphate groups. And creatine monophosphate can come along and donate its phosphate group, right? It's a phosphate donor, to replenish the ATP. It can turn the ADP into ATP by giving it its phosphate group. Why is this useful? Particularly when it comes to athletics or times of high energy demand, this creatine monophosphate system is useful because as ATP gets used up, there's kind of a gap before the pathways that produce more ATP, like glycolysis and cellular respiration, kind of kick in to fill in and replenish that ATP. The creatine monophosphate system will fill that gap. This is particularly useful when it comes to kind of high energy demand scenarios. So you think like sports where you're producing a lot of power or a lot of force in short periods of time. So like sprinting or weightlifting, stuff like that.